Hey everybody, welcome back to another edition in Geometry. It's Mr. Anderson here with you, leading you through a new section in Chapter 8. This time we're in Chapter 8, or Section 8.6. We're going to talk today about the law of sines and the law of cosines. Okay, so let's get going. First of all, our objectives today, we are going to use the law of sines to solve triangles, and then use the law of cosines to try and solve triangles. All right, so first of all, the law of sines. Okay, so remember what we've been talking about recently has been everything has been a right triangle. Okay, so everything has had 90 degrees as one of the angles in our triangle. Well, the law of sines, what we're going to talk about here first, can be used for any triangle. Okay, so it doesn't have to be 90 degrees. That's the first important thing here. Some of the ways that this is used the most often is if you know two angles, any two angles and a side. Okay, so if you know any two angles and a side, this can be very useful. All right, so here's kind of the official thing. Now, don't let this get all scary on you here, but let me explain this a little bit. All right, so here's the formula. This is what you need to kind of remember this right here. The sine A over A equals sine B over B, sine C over C. So notice, first of all, that big A is just this vertex of the triangle. The small a here is the opposite side. Okay, so small a is the opposite side from the angle A. The small b is the side that's opposite from angle B. And the small c is the side that's opposite from angle C. Okay, so in this situation then, if that's what we're going to call these, that means any time we take the sine of the angle over the opposite side, the length of that side, it will be equal to all the other ones. Now what we're going to do is when we use this, we're only going to usually just use 2 out of the 3. So if you know A and B, make those equal to each other. If you know B and C, make those equal to each other. If you just know A and C, you can also make those equal to each other, and then we'll solve it. Okay, so let's just look at a few examples. I think you'll find it to be pretty straightforward. All right, we want to find P. We're going to round to the nearest tenth. So here's P. So what we have to do is match up, remember, the angles and the sides. So here's angle 17 degrees. Remember, that matches up with the side that's across from it. And the 29 degrees right here matches up with a side that's across from it. So it doesn't really matter which one's A or B or C. We're just going to write this with the ones that we know. So I'm going to start by saying the sine of 17 over P would equal the sine of 29 over 8. Okay, so it doesn't matter which one's A or B, but you notice it always has to match up with this angle and the side that's straight across from it. So sine of 17 over P, sine of 29 over 8. When you look at this now, you say, hey, that looks like a proportion. Do you remember how we solve proportions? Remember when we talked about that a little while ago? We cross multiply, or if you remember, the butterfly method. Okay, so that's all we're going to do here. Just like we've done before, we're just going to cross multiply. So I'm going to go P times the sine of 29 will equal this cross product, 8 times the sine of 17. Now, if you remember from what we just have been talking about in the last section or two, the sine of 29 is just a number, and it's being multiplied by P. So anytime you have a number times P, you can just divide by that number to get rid of it. So I'm going to divide by the sine of 29 on both sides. The sine of 29 cancels out, and so now I've got P equals 8 times the sine of 17 over the sine of 29. So I've got P by itself. I just have to type this in my calculator now. So calculator. There we go. So here's my calculator, and we're just going to type this in here. So I'm going to go 8. Let's try that again. 8 times the sine of 17, close parentheses, divide by sine of 29. And I hit equals, and this said round to the nearest tenth, and so that's going to be then, looks like 4.8. So P, would be about 4.8. Okay, that's not too bad, right? Shrink that down. So just using the law of sines. Let's do another one. Notice this one was using angle, angle, side. So notice we had an angle, then the next angle, and then a side. So there was an angle, and a side, and that worked out how we did that. Now in this one, you notice this law of sines, but in this case, again, we have two angles and a side, but this time the side is in between the two angles. So you notice, here's our two angles. There's a side, or the side is in between the two angles. Okay, well, let's match stuff up. So here's my 43 degrees. That matches up with this side. So we could say the sine of 43 over x would equal what? If you look at the 15, you go, oh, wait a minute. There's nothing that matches up with the 15. Look at the 55. Oh, there's nothing that matches up with that. How is this going to work? Okay, well, remember, this is a triangle. And in a triangle, we have 180 degrees. So if I just take 180, subtract 55, and then subtract 43, so I just take these, 180 minus 55, minus 55, minus 43, that will tell me 82. All right, so what's 82? Well, that's this other angle over here. So this is 82 degrees. Oh, now that I've got this angle here, now this angle will match up with that side. So going back over here, sine of 82 over 15. It's a proportion, so let's do our cross multiplying. So that's going to be x times the sine of 82 will equal this 15 times the sine of 43. Since we want to find out what x is, let's divide by the sine of 82. Cancel and cancel. So in this case now, x is going to equal 15 times the sine of 43 all over the sine of 82. All right, calculator. And so we're going to type in here 15 sine of 43, close parentheses, divided by sine of 82. And so that's going to give us about 10.3. So I think, again, that was to the nearest tenth. Yeah, so 10.3. So x would equal approximately 10.3. Okay? So that's law of sines. Basically, you're just matching up the angle with the side across from it and getting two things to be equal to each other, cross multiplying, getting x by itself. If you don't know the angle here, then just subtract these from 180 to find that angle so that you can match that up. Okay, so there's the law of sines.